Now, sometimes our integrals don't fall nicely into line with one of our standard forms, and so we have to use other techniques. Now, this is a great problem because it doesn't fall into one of our standard forms, but I recognize I've got something squared minus something squared under a radical. So what if I just start out with letting u squared equal e to the 2x, so that u is e to the x, and du is e to the x dx. Now I want to solve this for dx. This is dx is du divided by e to the x. But I want this all in terms of u if possible, and u is e to the x, so this is du divided by u. Now let me look at this 1. If I let a squared equal 1, a is equal to 1. Now let's see what happens when I plug this back into my integral. See if this got me anything. Dx is du divided by u, square root. Now e to the 2x is u squared, minus a squared. Now I have this fallen into my lap as the inverse secant of the absolute value of u over a plus c. So this becomes the inverse secant, the absolute value of u. Now I don't need the absolute values because e to the x is always positive, divided by 1 plus c. Now, sometimes you have to rewrite. The first thing I would do here is say, do I have just a straightforward u substitution so that this is u, but the derivative of 4 minus x squared is minus 2x squared, and minus 2x, and I don't have that quite yet. So what if I break this into two integrals? What if I say this is the integral of x dx divided by the square root of 4 minus x squared plus 2 times the integral of dx divided by the square root of 4 minus x squared. Now I have two separate integrals, and I'm going to do them in two different colors. For the first one, this is of the form of a nice u substitution. If I let u equal 4 minus x squared, du is minus 2x dx. So x dx is minus du over 2. So when I plug back in, again, I'm just doing this first integral. This is the integral of, let's see, I'm going to put the minus 1/2 out here, du divided by, now this is u, so this is u to the 1/2. Oh, that's a mess. So this is minus 1/2 times the integral of u to the minus 1/2 du. Okay, so this is minus 1/2. I raise the power by 1. So this is u to the 1/2 divided by 1/2 plus c. So this first one, those cancel, is minus, and this is going to be the square root of 4 minus x squared. So this is the first part. I'm going to come over here and do the second integral in red. Let's see, let me rewrite it because that's not very neat. Dx divided by the square root of 4 minus x squared. I'm going to let x equal u, so dx is du. And then I'm going to let a squared equal 4, so a is 2. So this one just falls right on out into the form of 2 times the inverse secant of x over 2 plus c. So my solution, when I combine these two together, this whole integral is equal to minus 4 minus x squared, and I'm not forgetting my square root, plus 2 times the inverse secant of x over 2 plus c. Now there's another technique that is sometimes helpful. Remember, sometimes you have to complete the square. Remember doing this in pre-calc so that you can get an integral in a nice form. Now, let's look at this integral right here. Dx divided by x squared minus 4x plus 7. This isn't in a nice form, so let me look at x squared minus 4x, and I'm going to put the plus 7 here. Now, if I add 4 here, I will get a something that I can complete the square. But if I add 4, I have to subtract 4. So this becomes x minus 2 squared plus 3. So I'm going to replace this with dx divided by x minus 2 squared plus 3 integral. Now it's pretty straightforward. I want to let u squared equal x minus 2 squared. So u is x minus 2, and du is equal to dx. I want to let a squared equal 3, so a is the square root of 3. Now my integral is of the form of an arctangent. And I know that the integral of arctangent is 1 over a. I'm not going to rewrite all this. So this is 1 divided by the square root of 3 times the inverse tangent of u over a. So this is x minus 2 divided by the square root of 3 plus a constant.